హలో ఎవ్రీవన్, వెల్కమ్ టు అవర్ ఛానల్. మనం నిన్న మీన్ ఆఫ్ పాయిజన్ డిస్ట్రిబ్యూషన్ గురించి నేర్చుకున్నాం కదా. ఈరోజు వేరియన్స్ గురించి తెలుసుకుందాం, అనగా న్యూ ది సెకండ్ సెంట్రల్ మూమెంట్ ఆఫ్ పాయిజన్ డిస్ట్రిబ్యూషన్. సో we will learn today about the variance. Variance of Poisson distribution. మీరు ఇంతకుముందు వీడియో కనుక చూడకపోతే ఫస్ట్ మీన్ చూసేసి ఈ వీడియో చూడండి, అప్పుడు మీకు ఈజీగా అర్థమవుతుంది. ఈ లింక్ని నేను డిస్క్రిప్షన్లో కూడా పెడతాను. పాయిజన్ డిస్ట్రిబ్యూషన్ అంటే ఏంటి, పాయిజన్ డిస్ట్రిబ్యూషన్ని ఎక్కడ వాడతారు అనేది కూడా ఆ లింక్ కూడా డిస్క్రిప్షన్లో పెడతాను. ఒక్కసారి చూసి ఈ వీడియో చూసేయండి. Therefore, mu2 dash is equals to expectation of x is equals to summation x is equals to 0 to infinity x square into p of x. We know the PMF of Poisson distribution, which is nothing but e to the power of minus lambda into lambda to the power of x by x factorial, where x takes the values from 0, 1 and so on up to infinity, where lambda should be greater than 0. And I am writing this x square as, ఈ x square ని నేను ఇలా రాసుకుంటున్నాను, x into x minus 1 plus x లా ఈ x square ని ఇలా రాసుకుంటున్నాను నేను. I can write in this way because x into x is x square minus x into 1 is x plus x. For plus x minus x cancel and we get x square. So I can write x square as x into x minus 1 plus x. Therefore mu2 dash is equals to summation x is equals to 0 to infinity x into x minus 1 plus x into p of x. Multiply this square bracket term with p of x. Therefore summation x is equals to 0 to infinity x into x minus 1 into p of x plus summation x is equals to 0 to infinity x into p of x. Therefore summation x is equals to 0 to infinity x into x minus 1 and p of x is equals to e to the power of minus lambda into lambda to the power of x by x factorial plus, in the previous video we have got summation x is equals to 0 to infinity x into p of x is equals to lambda. Therefore I am denoting it as lambda. I am writing here summation x is equals to 0 to infinity x into p of x is equals to lambda. Therefore summation x is equals to 0 to infinity x into x minus 1 e to the power of minus lambda into lambda to the power of x by, I can write this x factorial as x into x minus 1 and x minus 2 factorial plus lambda. Here e to the power of minus lambda is constant because there is no x term in this. So I am writing this in the outside. Therefore e to the power of minus lambda into summation x is equals to 0 to infinity x into x minus 1 into lambda to the power of x by x into x minus 1 x minus 2 factorial plus lambda. So I can cancel this x into x minus 1 and x into x minus 1. Therefore we get e to the power of minus lambda into x into lambda to the power of x by x minus 2 factorial plus lambda. So see here, I can write this lambda x. Lambda to the power of x has lambda to the power of x minus 2 into lambda to the power of 2. Therefore, here the bases are same. So I can add the powers. Lambda to the power of x minus 2 plus 2. So I can easily cancel this plus 2 and minus 2. Therefore, lambda to the power of x. So I can write lambda to the power of x as lambda to the power of x minus 2 into lambda to the power of 2. E to the power of minus lambda. Summation x is equals to 0 to infinity. Lambda to the power of x minus 2 into lambda to the power of 2 by x minus 2 factorial plus lambda. So here see PMF lambda to the power of x. So here we have x has x minus 2. Therefore x is equals to x minus 2. Therefore x minus 2 is equals to 0. If we take this 2 outside, then we get x is equals to 2. Here the lambda square is constant because there is no x term in this. Therefore I am taking this outside. E to the power of minus lambda into lambda square summation x is equals to 2. X is equals to 2 to infinity and lambda to the power of x minus 2 by x minus 2 factorial plus lambda. Therefore, e to the power of minus lambda into lambda square summation. So I can write this summation, this one. This term I can write as lambda to the power of x minus 2 factorial where x is equals to 2 plus lambda x minus 2 by x minus 2 factorial when x is equals to 3 plus lambda to the power of x minus 2 by x minus 2 factorial when x is equals to 4 and up to so on x is equals to infinity. So if I substitute here lambda square when x is equals to 2, therefore 2 minus 2 is 0. Lambda to the power of 0 is anything to the power of 0 is 1. 1 by 2 minus 2 is 0. 0 factorial is equals to 1 plus lambda to the power of x minus 2. X is equals to 3. 3 minus 2 is 1. Lambda to the power of 1 is lambda. Lambda by 3 minus 2 is 1. 1 factorial is equals to 1 plus lambda to the power of 4 minus 2. 4 minus 2 is nothing but 2. Lambda square by 4 minus 2 is 2. 2 factorial is 2. 2 into 1. 2 plus now the x value becomes 5. 5 minus 2 is 3. Therefore lambda to the power of 3 and 5 minus 2 becomes 3. 2 factorial and 3 factorial plus so on. Here in the previous video only I have said the formula about e to the power of t which is equals to 1 plus t square by 2 factorial plus t cube by 3 factorial and so on. So if you see this form and this form which is the same, so I can substitute e to the power of t. Here the variable is t. Here the variable is lambda. So I can write it as e to the power of minus lambda into lambda square e to the power of lambda. So I get multiply the square bracket term with the outside terms. Therefore e to the power of minus lambda, bases are same, so we add the powers. So plus lambda into lambda square and we also have plus lambda here. Please don't forget about it. Plus lambda and plus lambda. Therefore, e to the power of minus lambda plus lambda is e to the power of 0. Anything to the power of 0 is 1. Therefore, 1 into lambda square plus lambda. Therefore, mu2 is equals to, mu2 dash is equals to lambda square plus lambda. We know that the second central moment mu2 is equals to mu2 dash minus mu1 dash square. So we need to substitute this mu2 dash and mu1 dash in this formula. Mu2 dash is equals to lambda square plus lambda minus mu1 dash. We got mu1 dash as, see here in the above, lambda. We got the mu1 dash is lambda. Therefore, I substitute here lambda. We have square, therefore lambda square, and plus lambda square minus lambda square cancel. We get mu2, the second central moment, and the variance of Poisson distribution is lambda. In Poisson distribution, mean is equals to variance. Therefore, mean and variance are same in Poisson distribution, which is equals to lambda. Please remember this one. These are the important relationship between the mean and variance of a binomial distribution, or mean and the relationship between mean and variance of Poisson distribution. In binomial distribution, variance is less than mean. But here in the Poisson distribution, mean is equals to variance. Thank you all.